Hey everyone, this is Tani. I know a lot of you are struggling with the med math, and you know that I'm actually doing pretty well in it, surprisingly. So I'm gonna do a video of the complex med math in Shadow Health and how I do it, and hopefully that helps you guys out. If you guys have any questions, please feel free to get back to me. Okay, let's do question one. Question one, the scenario is, suppose Ms. Turner's orders call for 500 milligrams of azithromycin to be administered intravenously for community-acquired pneumonia. The solution has been diluted to a concentration of 2 milligrams per milliliter and needs to be administered over 1 hour. So we want to end up with milliliters per hour. So we want to end up with milliliters per hour. So we'll write that down first. Now we have 500 milligrams is how much she needs. We also have 2 milligrams per 1 milliliter. And it needs to be administered over 1 hour. Now we know we want to end up with milliliters. Okay, so let's start with, we'll switch, like I said, we can switch these. 2 milligrams over 1 milliliter is the exact same as 1 milliliter over, forgive my M's, 2 milligrams. So we'll start with that. 1 milliliter over 2 milligrams. And we know we want to cancel out the milligrams, so we're going to input 5 milligrams. And we want this 5 milligrams to be given over 1 hour. So, but we also know, so we know that we want milliliters per hour, so we do not have to turn hours into minutes like a lot of these say. So all you have to do is that, and that will cancel out the milligrams and give you milliliters per hour. So it'd be 500 divided by 2. So let's do the math real quick. 500 divided by 2 would equal 250. So that'd be 250 milliliters per hour. So let's put that in. $250 milliliters per hour. And that's the right answer. Okay, now we're going to move on to question 2. Question 2 is Mrs. Turner's daily medications include venlafaxine, extended release, 150 milligrams per mouth once a day. However, the hospital pharmacy only carries 75 milligrams extended release tablets. Now that one's pretty easy. You just do 150, how much she needs, over how much they have. So that would just be 150 divided by 75. Would equal 2 tablets. So let's put that in. 2 tablets. And that's correct. I probably should have stayed on that slightly longer. 2 tablets was correct. But I think a lot of us at least have those ones down. Okay, so this one is, suppose Ms. Turner's provider updated her order for 325 milligram, 2 tablets by mouth, every 6 hours. Q6RH means every 6 hours. PRN temp is greater than 38.05 Celsius to 325 milligrams. We already know this one is going to have a lot of things that don't apply here. So, let's kind of go into this. Okay, so I like to write it down a little bit. Okay, so we have her order is going to be 325 milligrams, 2 tablets by mouth every 4 hours. Q4H. Okay. And the Q4H. Wait, hold on. Shit. Okay. Sorry. That's Q6H. So that's gonna matter on this one because this one is, what is the recommended dosage? It has a maximum recommended dosage of 4 grams per day, and it's saying how many doses can Miss Turner take without exceeding the recommended dosage. So recommended dosage is 4 grams per day. We're given everything in milligrams, so we're going to have to transfer the 4 over to milligrams. This is pretty easy. Think of it as a 4.0. So for milligrams, we're going to move the decimal place over 3 places. 1, 2, 3, and it would be 4,000 milligrams. You can use your conversion sheet, do the math if you want, but I find that's the easiest way I do it. Okay, so she can take 4,000 milligrams per day. Now let's see. They updated her order. So her current order is 325 milligrams Q6H. But that was her previous order, and they said they've updated her order for this to, so this order doesn't matter. So they've updated the order to 325 milligrams, 2 tablets, Q4H. So she now takes the 325 milligrams, 2 tablets, every 4 hours. But I suppose that doesn't really matter. How many hours actually doesn't matter. It's just kind of figuring out what it means in her head. That doesn't matter because it's 325 milligrams per tablet. But we take 2 tablets, so we're going to times 325 by 2, which would give us 650 milligrams per dose. Because you take 2 tablets of this, so we'd have 650 milligrams per dose. We all should know this one by now because everything seems to be given, especially acetaminophen and stuff, seems to be given at 325 milligrams. So we have 650 milligrams per dose. Milligrams per dose, and we're wanting to know how many doses we can take per day. And we are allowed to take 400, and we're wanting doses per day. So we're going to need to swap these. So we're going to do one dose is 650 milligrams, and we have 4,000 milligrams per day. Wait. Yeah. Because we're going to want doses per day. So 1 dose is 650 milligrams. And this will give us doses per day. Cancel out the milligrams. So there's just a lot in there, but thankfully it ends up being just these 2 numbers. 4,000 divided by 650 equals, she can take 6 doses per day. It doesn't say to add, so let's put that in, 6 doses per day. And yeah, that's the correct answer, 6 doses per day. So that one had a lot of distractors in it. We didn't even need to know, like, the previous or the updated because it didn't matter. They're not asking, like, how many she's going to take after this amount of hours or anything. They're asking how many doses she can take per day. Okay, let's do question 4 now. Question 4 states, suppose Ms. Turner's current temperature is 38.22 Celsius. For temperatures greater than 38.05, the prescriber's order allows acetaminophen 325 milligrams, 2 tabs by mouth every 6 hours. Assume that on her first day at hospitalization, Mrs. Turner's temperature is greater than 38.05 3 times. How many... So I guess the current temperature doesn't really matter. All we care about is that on the first day. They're asking how many grams of acetaminophen... How many grams? Okay. Of acetaminophen will Miss Turner have ingested on her first day? Now... Pay attention, that seems a little bit of a trick question. On this, they're asking for how many grams, not how many Damn it, hold still. not how many milligrams. Sorry, still trying to figure out how to... Ah, no, attack. Use this thing. Let me, hold on. And we're back. That was complicated. All right, so they're saying her temperature went up 3 times, and each time she was given an order for 325 milligrams, 2 tablets. So each time she was given 650 milligrams, and she was given that 3 times. This is not the one where we really need to do the train track method. It'd just be 650 milligrams times 3. So let's 650 times 3 equals 1950 milligrams. And I showed you so the decimal point would be right here, and we would move that over 1, 2, 3. So that'd be 1 point. Oh, sorry. So the decimal point's right here, and we move it 1, 2, 3. So that'd be 1.950 grams. If you want to take out the 1.95 grams. So let's put that in and see if we're right. 1.95. Yeah, 1.95. Sweet. All right, now for question 5. Bert's giving me the side eye. Now for question 5. Mrs. Turner's daily medication includes potassium chloride. Let's see, 10 MEQ tablet by mouth once daily. The hospital pharmacy will dispense potassium chloride 10%, which is 1.5 grams, or 20 MEQ per 15 milliliter. The potassium chloride liquid will be further diluted in a 6-ounce glass of water or juice administration. What volume of potassium chloride 10% liquid should be used for Miss Turner's daily dose? Okay, this one has a lot of things. Okay, but we know, it says right here, we know milliliters is going to be the units we want. So we're focused on that. Now, what has milliliters? It says 10% potassium chloride is equal to 1.5 grams or 20 MEQ. Ah, shoot. House is a bit haunted. Sometimes things like to throw themselves. Okay, so 10% potassium chloride is equal to 1.5 grams, or, remember the or is important, 20 MEQ per 15 milliliters. But we want to find out milliliters, so we know this is the distractor. That one doesn't matter, because it's an or, not an and. Okay, and so, and we know we want milliliters on top, so like I said earlier, 20 MEQ per 15 milliliters. Can also be swapped and equal, we want 15 milliliters per 20 MEQ. That's going to be our first track on the train tracks. Now we're also know she's given 10 MEQ tablets by mouth once daily. So we know that's daily, so that's her whole daily dose. And that's going to be it, actually. That'll cancel out the MEQs, and all we'll be left is milliliters. So it says a lot, but just focus on the units, because there was a lot said, but we know that if we just plug in these units and cancel them out, then we'll get the proper units, which is milliliters. So this would just be, and this is our first case where I can show that it doesn't matter like what order you put it in, you're going to get the same order. So we can do 15 times 10 divided by 20 will equal 7.5. Remember, everything on top we want to times by, everything on bottom we want to divide by. But you can also do a different order if we did 15 divided by 20 and then times 10 would equal 7.5. So just times everything on top, divide everything on bottom, and you'll get the right answer. Now let's put this in, see if the answer is 7.5. Yep, that's the answer, 7.5. Okay, this is question number 6. Now, it confused me at first, but once I figured out the units, it was pretty simple. So Mrs. Turner's original orders call for ceftriaxone, 1 gram, to be administered intravenously daily. The solution has been diluted to a concentration of 1 gram over 50 millimeters to be administered over 30 minutes. 20 minutes into the first infusion, Mrs. Turner reports an adverse reaction to the antibiotic, and the infusion is stopped. Now, we know that we don't want to end up with milliliters. It says how many milliliters was administered. So we'll put that up here. We want to end up with milliliters. Now, we know the solution is 1 gram over 50 milliliters, but we know we want milliliters to end up top. So we're going to swap that. Remember, you can swap that anytime. So it's 50 milliliters over 1 gram. We want to cancel out the gram. How much was she issued? Well, she was issued 1 gram. So, funnily enough, that cancels out. So that's great. But we also want to know the flow rate. How long was this supposed to be issued over? 30 minutes. So 30 minutes. So it'd be 50 milliliters divided by 30 minutes will give us the flow rate in milliliters per minute. So we can do that first. It's basically you just do 50 divided by 30. And that will give us the flow rate. 50 divided by 30. So the flow rate is, let's say, 1.67. 1.67. And yeah, I can still hear Omar going, 6.7, 6.7. I am too old to understand that phase. All right, okay. So we know our flow rate is 6.7 milliliters per minute. And we only gave the medication for 20 minutes. So 1.67 milliliters per minute over 20 minutes. That will cancel out the minutes. So 1.67 times 20 equals 33.3. It says round to the nearest whole number. So it says 33. So that would be 33 milliliters is the amount that we actually gave her. So first you just figure out the flow rate and then you times by the amount of minutes. So that is 33 milliliters. Ta-da! All right, we're going to go on to question number 7, which is... Okay, according to Mosby's drug guide, children 6 months or old or younger with community-acquired pneumonia can be administered azithromycin orally using a weight-based dosage. Children in this age group can receive 10 milligrams per kilogram on the first day, then 5 milligrams per kilogram for 4 more days. Assuming you need to administer this to a child weighing 20.3 pounds, what is the total dose of azithromycin the child received over 5 days? Okay, so let's start a new page for this one. First, we have 20.3 pounds. We're going to 20.3 pounds that we're going to transfer into kilograms. So we're just going to do 20.3 divided by 2.2 equals 9.23 kilograms. This is really like 9.2272, but we're going to round to the nearest hundreds. 9.23 kilograms. Okay, on the first day, we can give 10 milligrams per kilogram. So we know 10 milligrams per kilogram times 9.23 kilograms. So it'd just be times 10 equals 90. That'd cancel out the kilograms, and that would be 92.27. We're going to continue running the 100 milligrams. That's day 1. And then after that, then we'll get 5 milligrams per kilogram. Well, per day. 5 milligrams, and we know we want 5 days. So whatever we get, we're going to times it by 5. But it's basically, we do the same thing, 5 times 5, 0.9.23 kilograms. And over, oh shoot, hold on. It'll not be over 5 days because they're asking how much will the child receive over 5 days. This is over the first day, so this will only be 4 days. So this will be the next 4 days, how much they will receive. So let's do the same as we did in the first one. 5 times, well, 10 times 92, it'd be 9.23. Shoot, I'm sorry. Going off track there. 9.23, wait. 5 times 9.23 would equal 46.15 milligrams. Now we just, times 4. I forgot to times by 4. So times 4 equals 184.6 milligrams. So let's just take that 184.6 milligrams plus the 92.3 milligrams. Okay, so we take those 4 days plus the 92.3 first day. We get 276.9, round to the nearest whole number, 277. 277 milligrams. Now let's plug that in. That over 5 days, we will give 277 milligrams. Yep, correct. So 277 milligrams. Okay, let's move on to question number 8. This one is Mrs. Turner's order calls for 50 micrograms of levothyroxine by mouse daily. The pharmacy stocks medication in 0.025 milligrams tablets. This one we did earlier. It's one of the easier ones. You just have required over desired. So required over given, I guess. So she needs 50 micrograms, but they stock 0.025 milligrams. Oh, okay. First, we need to change 0.025 into micrograms. Or 50. You gotta put them on the same. It doesn't matter if you change 50 into milligrams or 0.025 into micrograms. You have to have the same units. So I'm gonna start. I'm gonna change 0.025 from milligrams into micrograms, and all we're going to do is move this 3 decimal places over. So it would be 0.025, zeros don't count, so it would be 25 micrograms. So we'd have 50 micrograms over 25 micrograms. So how many tablets does she need? Should be 2. 50, 25 goes into 50 twice. So let's put that in here. So like when reading these, just be careful about what units they say. You may need to change over the units. So let's try 2 tablets. And that's correct. 2 tablets. Okay. Okay, now we'll go to question 9. At home, Miss Turner takes 45 units of long-acting insulin Glargine SC daily, SC subcutaneous. She also takes insulin, aspart, SC, TID, I think that means 3 times a day, at meal times using the sliding scale. And one day, Miss Turner's blood glucose readings are... Okay, so this sliding scale is what blood glucose, how many units she'll take, depending on what her blood glucose is. And in one day, Miss Turner's blood glucose readings are 160 at breakfast, 180 at lunch, and 200 at dinner. How many total units of insulin does Miss Turner take on this day? So we know she takes, let's break this up into multiple parts. We know she takes 45 units daily, regardless of anything else. So we're going to mark that down. And then the others she takes 3 times a day at breakfast, lunch, and dinner, or at meal times. So this one she takes, at breakfast, she has a blood glucose of 160. So this says 150 to 199 should take 3 units. So at breakfast, she'll take, we'll just say the first time a day, she takes 3 units. Now at lunch, she had a blood glucose of 180. Now she'd still be the 3 units because her blood glucose was between 150 and 199. So she took another 3 units of insulin at lunch. Now at dinner, her blood glucose was 200. Now this one says 150 to 199 is 3 units, which means we would go up to 5 units. Blood glucose 200 to 249. So at dinner, she took 5 units. This is just in addition. Okay, so she took 45 units plus 3 units plus 3 units plus 5 units. So that's 45, 50, 53, 56. 56 units is how much she took of insulin, is how much she took in one day. So let's put this in and see if it's the right answer. 56. Yeah, 56 units. Sweet. We're going to do question 10. Question 10, the scenario is, assume that the provider orders insulin, aspart, I'm not sure how to pronounce that, on a sliding scale from 1 unit per 10 grams CHO subcutaneous plus 1 unit per 50 points above 150 blood glucose. So Miss Turner will eat a meal that contains 40 grams CHO and has a pre-meal blood glucose level of 160. Okay, that's a little confusing. Let's break it down into parts. First, she has... let's start on the page so it can be clear. First, she has 1 unit per 10 grams CHO. Okay, and now we're told she has... So we'll just put that into a little train track, and we're told she has 40 grams CHO. Alright, so we'll just... And that would tell us how many units. So 40 divided by 10 is 4. So she has 4 units. And then that would be plus... So this is just 2 different calculations that we add together. So 1 unit per 50 points greater than 150 BG. Okay, so 160, she has 160 blood glucose. Now that's 160, if you subtract 160 minus 150, it's only 10 points. So her blood glucose is only 10 points above the 150, so she wouldn't get any additional units. That should say she doesn't get any additional units, which means she should only get those 4 units. So let's see if that is correct. 4? And that is correct, yes. So if she did have, I would say though, if she did have, like, instead she had a blood glucose of 200, then we would do 200 minus 150, and we would see that was 50 points above. And we would give her an additional unit. Or if she had a blood glucose of 250, we would do 250 minus 150, and then we would see that's 100 points. And that's 50 times 2, because it's each 50 points. So in that case, she'd get 2 units. That's what it means by 50 points above. So like every time you get above 50, or if it had 280, then it would still be only 2 units, because it's only 250s above 150. Or if it had 220, then she would still only get the 1 unit. But because she didn't have 50 points above, she didn't get any of those units. If that makes sense, hopefully. Let's move on to question 11. Question 11 is, suppose Mrs. Turner's provider writes a revised order of 25 milligrams of her daily levothyroxine. Given that her original order was in micrograms, you suspect this new order contains an error. You take the appropriate measures to get the orders corrected in order to avoid administering an overdose. If the error had not been caught, how many times more levothyroxine would have been given than was ordered? Okay, we have to go back to... well, that one, I don't think we have to go back to the previous one. Okay, so let's see. Let's assume we're going to have to do this calculation twice. Okay, she gets 25 milligrams. And she's supposed to get 25 micrograms. So let's convert 25 milligrams to micrograms. So this would be the decimal point, and we would need to move over 3 times. So that would be 25,000 micrograms over 25 micrograms. So let's do the math on that one. How many times does 25 go into 25,000? 25 to 3 divided by 25 equals 1,000 times. It says use a comma above anything over 999. So let's put it in right here. 1, comma, 0, 0, 0. Comma is important because this is just an AI reading this, or whatever it is. Yep, so that'd be, you would be giving 1,000 times the dose, which 1,000 times the dose is generally often a lethal dose, or going to fuck your shit up. This is why the units are so important. 12. Suppose Mrs. Turner's provider orders 500 milligrams of azithromycin to be delivered in a 250 milliliter IV solution over 3 hours. The dose will be delivered using IV tubing with a drop factor of 15 GTT. What is the appropriate rate of flow for the IV in drops per minute? So this is another one. We're going to focus on the units. So the units they want is GTT per minute. That's the units they want. Now let's go over what we have. We have the 500 milligram solution. So the 500 milligrams, that doesn't matter, because the 500 milligram solution is equal to 250 milliliters over 3 hours. So that's what we know we have. Now we also have 15 GTT is per 1 milliliter, because it says 15 GTT equals 1 milliliter. So 15 GTT per 1 milliliter. So we'll do 250, because we want hours on bottom. So 250 milliliters per 3 hours times the 15 GTT per 1 milliliter. Now we also know that what we want to end up with is GTT per minute. So that's minute, not hours. So we're also going to add in 1 hour is same as 60 minutes. So that'll cancel out the hours and the milliliters. And we'll be left with GTT per minute. So let's do the math. That'd be 250 times 15 divided by 3 divided by 60. Everything on top you times, everything on bottom you divide. So that would be 20.83 GTT per minute. Now it says round to the nearest whole number, so it would equal 21 GTT per minute. So we want 21 GTT per minute. Let's go ahead and put that in, and I already did. And ta-da, 21 GTT per minute. Right now we're going to go over question 13. Question 13. On the second day of hospitalization, Miss Turner's orders call for 500 milligrams of zithromycin to be delivered in a 250 milliliter IV solution over 3 hours. The dose will be delivered using IV tubing with a drop factor of 10, which is 10 GTT. What is the appropriate rate of flow for the IV drops? IV and drops per minute. Remember, drops are the GTT. Okay. So, where did I set my pen? So, here we go. Now, what we have, again, we have the 500 milligrams, but the milligrams doesn't matter because they've already done, because it's to be delivered in a 250 milliliter IV solution over 3 hours. So, like the previous question, the 500 milligrams doesn't matter. The other thing we know is that 10 GTT is equal to, which is same as like 1 milliliter. So we have 10 GTT per 1 milliliter. And what we want to end up with is GTT per minute. So we have the units we have and the units we want to end up with. And those actually, so these are each their own railroad tracks. So again, 250 milliliters over 3 hours is one railroad track, and 10 GTT per 1 milliliter. It's another railroad track. And with this one, as per the other one, we know that we want GTT per minute, not hours. So 1 hour over 60 minutes. So I hope that's all it. So milliliters will cancel out, hours will cancel out, and you'll be left with GTT over minutes. Now let's do the math real quick. So that's 250. And like I said, it doesn't matter. Everything on top you times, everything on bottom you divide, so it doesn't matter what order you do it in. 250 divided by 3 times 10 divided by 60 would equal 13.89. 13.89, and it says round to the nearest whole number, so that would equal 14 GTT per minute. Now let's put that in real quick, see if we get the right answer. 14 GTT per minute. And yep, that is the right answer, 14 GTT per minute. Hey, we only have 2 left to go. Yay! This is question number 14. So, assume that the provider prescribes Ms. Turner insulin as part aspart. I still don't know how to say that. Or what it means. 16 units subcutaneous TID, which means 3 times a day at mealtimes. When Mrs. Turner returns home, the provider would like to switch her mealtime insulin administration to a pen delivery device instead of insulin syringes. The provider will keep the same dose. Assume that Mrs. Turner eats 3 meals a day. The pen cartridges contain 3 milliliters of unit 100 insulin aspart. How often will Mrs. Turner need to replace the cartridge? Okay, I'm gonna hold on. So I googled what U100 means, and U100 means 100 units of insulin per milliliter of fluid. So, sorry. So U100 actually means 100 units per 1 milliliter. Okay, let's go back to the question. So, she's going to take 16, it says she's going to take 16 units 3 times a day at meals. So, right now she's got, we know these cartridges contain 3 milliliters. So these cartridges are 3 milliliters per 100 units. Each cartridge is 100 units per 1 ml times 3 milliliters. So each cartridge is, well, 300, but each cartridge is 300 units because it's just 3 times 100. So each of these 100 U100 cartridges are 300 units. And she's going to take 16 units, so she takes 16 units 3 times a day. So 16 times 3 would equal, I don't know if I'm supposed to know how to do, I'm not good at doing math in my head. 16 times 3 equals, okay, that's 48. So 48 units. She'll use 48 units a day. 48 units a day. So that's 48 units per day. And we know we want day to be on top because it's how many days. So we would turn that into a day over 48 units, which is great. And that means we know that 300 units needs to go on top. And we need to divide 300 units divided by 48 units. Well, hold on, let's write it. So 300 units is its own trade track, and then we 48 units per 1 day. So that will cancel out the units. We'll just divide 300 by 48. That's how you know. So this is how you know which one to divide and which one to multiply and stuff. Well, that's how I do it in my head. Well, not in my head, on my paper. So 300 units divided by 48. Let's do that. 300 divided by 48. That would be 6.25 days. And it says round to the nearest whole day. So that would be 6 days. Okay, let's check it in. So sip. Sorry, hold on. 6. Let's see if that's right. And it's right. 6 days. Okay, it's going to be the last question. Yay! So, last question, question number 15. Okay, let's do, okay, question 15 is, assume that Mrs. Turner's provider decides to prescribe insulin aspart 16 units subcutaneous TID 3 times a day at meal times, and Mrs. Turner receives a U100 10 milliliter vial of insulin S part, assume that Miss Turner eats 3 meals a day. How long would a U100 10 milliliter of insulin, S part, last at this dosage? Okay, so we know from the previous question that 100 units is 1 milliliter. She says she got a 10 milliliter vial. So how many units is this? That's 10 times 100 would equal, you just kind of add the zeros together. So that would equal 1,000 units is how much medicine she was given, 1,000 units. Now let's figure out how many times she takes a day. She takes 16, and it's the same as before, she takes 16 units subcutaneously 3 times a day at meals, because it says TID, which is 3 times a day. So we'll do 16 times 3 would again equal 48 units is how much she takes per day. So we would, so that's 48 units per day. We'll pretty much do the same thing we do with the one. One day, she takes 48 units. We want the day on top, and so the day on top. And then we know she's given 1,000 units. So we just divide 1,000 by 48, and that will give us the amount of, because this will cancel out the units, and that will give us the amount of days we have. Okay, so it's just pretty much the same as the previous one. 1,000 divided by 48 equals 20.8. They say round to the nearest whole day, so that should be 21 days. So let's try that. 21. Okay, I must have done the math here wrong. Okay, no, it's not that I did the math wrong. So apparently, when you round to the nearest whole day, even though we got 20.8, which would round to 21, it says you round down, so, because 0.8 isn't a whole day, so, okay. So it says round to the nearest whole day. And so that would be 20 days. So, because 0.8 isn't a whole day. So that is where I went wrong. So if you're putting in here, you want to put in 20 days instead of 21. I know it says 20.8, but make sure you round down when it says round to the nearest whole day. Learn something new. All right.